Welcome back to Algebra 1. So our first step is we want to remind ourselves how we get a list of factors. And if we're looking at the factors of 42, I think it's useful to start with 1, then does 2 go into it? 2 goes into it times 21. Make sure you make them as pairs here. 3 goes into it, that's going to be times 14. 4 doesn't go into it, 5 doesn't go into it, 6 goes into it, times 7, and notice that I'm back up to 7, so I'm starting up the other list. Factors of 28, 1 and 28. Is it divisible by 2? Is it divisible by 3? Is it divisible by 4? Is it divisible by 5? By 6? By 7, yes, but 7 is already on my list. Factors of 60, 1 and 60. It's divisible by 2, that's 30. It's divisible by 3, that's 20. It's divisible by 4, that's 15. It's divisible by 5, 5 times 12. It's divisible by 6, 6 times 10. 7, no, 8, no, 9, no, and now we're back up to the other side. Factors of 36, 1 and 36. It's divisible by 2. It's divisible by 3. It's divisible by 4. Not 5, 6, yes, and since 6 is 6, we're already back up to the other side. When I say make a list of factors, this is what I want. I want them in pairs because we're going to use them in pairs. So our next step is to be able to use kind of the area method to factor a trinomial that has a specific format. There is no number other than 1 in front of the x squared. These other two terms, we're going to use b and c with those. That's going to help us with the pattern. So if we start and we think of the area method, all of our x squareds are going to go in this box here. The constant is going to go in this box here. So that's what they look like so far. And then we have this negative 3x. That negative 3 has to be split in between these two boxes. But how do we split it? We want to think about the constant and what two numbers multiply to get me this constant and add to get me this number, the negative 3. So negative 1 times negative 2 gets me positive 2, and negative 1 plus negative 2 gets me negative 3. So this negative 1 and negative 2 would end up going here with an x and here with an x. We'll actually have an easier place to put them in a moment. So if we have this, what does that make our factors? Well, our factors have to be up here and across the side here. And we already know that we're going to have an x here and here. And what we need is a factor to go here. Oh, that's where the negative 2 goes, and that's where the negative 1 goes. So here's one factor, and here, if we put it together, will be the other factor. So it ends up being my factored form is x minus 1. Oh, that minus 1 goes directly into the equation, and x minus 2. From there, we could solve, but our work today is to factor. Here's another example, so let's start it out this way. So we're going to put our x squared here. Whatever our constant is, we're going to put here. And then we're looking for the factors of 4. Well, the factors of 4 are 1 and 4, 2 and 2. Pair that adds to give me this positive 5 here are 1 and 4. So it doesn't matter which one we put the 1 in and the 4 in. And if we are thinking about what the factors are, this is going to be plus 1 this is going to be x plus 4. So there's our two sets of factors. So now, instead of going into the table first, let's think of what the factors would be. So out here to the side, we know we're going to have an x and an x. And our goal is factors of 12 that add to get me -7. So factors of 12 are 1 and 12, 2 and 6, 3 and 4. And that's going to be the entire list. In order to get this negative factor here, if they are both negative, negative times negative is positive. Negative plus negative stays negative. So I'm going to have a -3, a -4. And if I multiply those all out and test it, I would get x squared here, -3x, -4x, +12. When I combine like terms here, I would get exactly what I started with. Okay, now the only difference that I have here is I'm looking for +7. So in that case, it's going to be +3 and +4. And if I tested that out, now I'm going to have +3x plus +4x, giving me the 7. And so that is going to be my factors, x plus 3 and x minus 4. So here's the rule we follow. The form of the equation is x squared plus b, some number in front of x, plus c, our constant. We're looking for the factors of c that add to give us b. When both are positive, c and b are positive, both of the factors will be positive. So I'm going to look for my list of factors for my 6, and 2 times 3, 1 times 6. The one that adds to get me the numbers I want are 2, so it's going to be +2, and 3 plus 3. That's factored. We're done. Let's take a look at an example when it happens to have a negative. C is now positive, but B is negative. So it turns out that both factors are negative. I could go straight to going, hey, I know they're negatives. So now what do? I need to look at 1 and 18, 2 times 9, that would give me 11, 3 times 6, there we go, we got it. And that means we plug in a -3 and a -6. Okay, I don't have to draw out the area anymore. So if we're going to factor this, we know it's going to be x in both for the first positions. We're looking at factors of 16. That's going to be 1 and 16, 2 and 8. Oh, 2 plus 8 would give me 10. Since both are positive, that means both of my terms will be positive, and we're factored. Factoring these, the factors of 6 that add to give me +7, that means they're both going to be positive. And I'm going to have x plus 6 and x plus 1. Now in this case, c is positive and b is negative, so that means both of my numbers are going to be negatives. So if I do 2 times 6, it has to be both negative signs. And that's going to give me x minus 2 and x minus 6. Factored. Our second rule is when c is negative. So when c is negative, one factor ends up positive and one will be negative because negative times positive gets me negative. The way that I decide which one isn't going to be positive is looking at b. And if b is a positive, that means my larger factor has to be positive. If b were negative, my larger factor would be negative. So my factors of 6 are going to be 1 and 6, 2 and 3. My larger number has to be positive. That's going to make one of these two negative. One that works is -1 and +6, and we are factored. So we are once again factoring with a negative c. So since c is a negative, one thing has to be positive and one has to be negative. We can write those out right away. Then we're looking at the factors of, and this is also going to tell us that the larger one has to be positive. So it's either -1 and 21. -2, no, -3 times 7. Oh, that's the one that works. So my -3 and my positive is 7 factored. So in all of these, I'm looking to see, first off, is c positive or negative? Because if c is positive, they both have the same sign, and the sign in this case is going to be negatives. Factors of 3, 1 and 3, those are the only factors of 3, and they work, they get me 4. Positive, negative, they both have to be negatives. Factors of 35, that's going to be 1 and 35, not 2, not 3, not 4, 5, goes with 7. Since they are both negative, we add these up and we end up with -12. So those are the numbers I place in. Again, c is positive, so both numbers have to be the same. I might start out my list. 2 is going to go with 12. Oh, those two add to get me 14. -2 and -12. The order that we put these in does not matter. It's just when one is positive, one is negative, you got to get those right. Factors of 15, 1 and 15, 3 and 5. The difference here is c is now negative. That means one of them has to be negative. Because b is positive, my smaller number would have to be negative. And now my second group is the one that works. So I have -3 and +5. Factors of -30. That's already going to tell us one is negative and one is positive. Because the 13 is positive, that means the larger number has to be positive. So I could have -1 going with 30. That doesn't work. -2 would be with 15. Oh, that's what works. So -2, +15. Factors of -42 that add to give me, well, one is positive, one is negative. So factors of 42, we had already made up this list, and notice that this is a very small number. It's -1. So my numbers end up being +6 and -7. And there we have factors. That is what you're doing today. Now we can end up with some word problems that deal with this, and we know that the area of a shape that is rectangular is going to be base times height. So this is the pumpkin patch over here, and we have the side of the square is S. So far we have this part is 30, so this part has to be S minus 30. The top part of the rectangle we're subtracting 40 from, so this one has to be S minus 40 to get to the side of the pumpkin patch. So the equation for the area is base times height. The one thing I don't like about S's is they look like 5s. Make sure that you know their S's is 600. Well, that's not going to work because I don't have it equal to 0. And that's the magic number, remember? So what I'm going to have to do is start off by foiling this. So I'm going to end up with squared minus 30s minus 40s. First outsides, insides, lasts, and positive 1200. That equals 600. The reason I FOILed this out is now I can subtract 600 from both sides, getting me a problem that has a solution of 0. And now what I have to do is refactor this. So factors of 600 that add to get me negative 70, that's going to end up being s minus 60 and s minus 10. So if you remember the shortcut on this, my possible solutions for this are going to be change the sign when you take it out, change the sign when you take it out. When I look back at the problem, would it make sense for this side to only be 10 if I have to take away 40 from that? So this number is not going to make sense, and my solution has to be that the side is 60 meters. Okay, your homework is on Google Classroom, and please private message me if you're having any problems. Have a good day.